All right, so let's do 11-2. 11-2 is about permutations. So we have 5 exclamation mark. 5 exclamation mark. That's not really a technical term. It's called 5 factorial. 5 factorial. 5 factorial. It's an excited 5. 5 factorial.
I thought it was a mess up.
No, not a typo. So 5 factorial is the product. So what does product mean? Add, subtract, multiply, or divide? Multiply. So we are going to multiply all positive integers from 5 down through 1. So for example, 5 factorial would be 5 times 4 times 3 times 2 times 1. So if you put this into your calculator, what would you get? Putting this into your calculator, what would you get? 120? Perfect. Thank you. That's it. So by definition, 0 factorial is going to be 1. So we usually stop at 1. So if we have 0 factorial, it's just 1. That's all we have. So what if you have 30 factorial? I'm lazy. I don't want to put in 30 times 29 times 28 times 27, all that good stuff. So our calculator will do this for you. So that way also for the 0 factorial, you don't have to memorize it. You can just plug it into your calculator. So if we have one of these calculators, I will also show you a graphing calculator way. So if you have a graphing calculator, I will show you that option after this one. So if you have one of my scientific calculators or one like this. So if we want to do 5 factorial, we're going to type in 5. And we're talking about permutations, right? This is this PRB button. PRB right here. We're going to hit that button. It should look like this. We good so far? Scrolling over to the exclamation mark. Press enter. That'll give us 5 factorial. Press enter again. Boom. So our calculator will do it for us. So same thing, if we have 0 factorial, so pressing the PRB button, scrolling over to the exclamation mark. Oops, I'm sorry. Went too far. Press enter. So 0 factorial, boom is 1. It'll tell us everything. Questions about scientific calculator. How could I help you before we move on from this part, this one?
Could you put in 30 and kind of explain how we use that answer?
30 factorial?
Yeah.
So like 30. You really wouldn't have anything this big, by the way. But so PRB, so factorial. So what this is saying, this crazy number is saying, it's scientific notation. So because it's so big, because it's 30 times 29 times 28, it's saying take this number and times 10 to the 32nd power. So it's in scientific notation. So you have to move the decimal 32 times to the right. So really big, which would make sense that it's really big because it's a lot of stuff going on. Nothing that crazy, so don't worry too much about it. But just scientific notation, because our calculator only has so much screen. Does that answer your question? Thank you. Other questions? Yes, ma'am.
Okay, so like on some of the homeworks, my calculator would have like a really big number, and it would say like E to like the 3rd power.
Yes, exactly.
Is that like the same thing?
The same thing. E is automatically telling you that it's a really small number, so go to the left. But it's scientific notation. That's exactly what it is.
Because I kept like getting them.
And you're like, what the heck is going on? Yeah. Yeah, no, you're good. It's same exact concept. Do you have this calculator? Yes.
Yeah.
So this one doesn't do, this one does like the actual scientific notation. Same exact concept. Yes, ma'am. We just did 5 factorial. She just asked me for 30 factorial just to talk about it. So something for this, like say you had this as an answer. So I would just put it exactly like this. But we're not going to have something that crazy. So don't worry. We had 5 factorial, so it was 120. That's it. Other questions about scientific calculator? We're going to do more factorial stuff. I just want questions about putting it into your calculator. All right, so if you have a graphing calculator, so anything, whether you have an old one like mine, my old faithful, or if you have a newer version, it'll all be the same buttons. So if we want to do 5 factorial, we're going to type in 5. We're going to hit the math button. It's the third button down on the left-hand side. So hitting the math button, you're left up with this menu. We're going to scroll all the way over to PRB, just like we did on the scientific calculator. And we're going to scroll down to number 4. Press enter. You have 5 factorial. Press enter again. Boom, you get 120. Questions about graphing calculator? Questions about graphing calculator? Show of hands, just so that way I can like more easily help you. Who has a graphing calculator? Okay. That's fine. I was just wondering. All right, so let's keep going. So the number of possible permutations if R objects are taken from N items is given by NPR. So this is supposed to be, so that way you can more easily understand it. These are subscripts. Subscripts. And we'll talk about this more in a second, but we have a formula for this. The formula is n factorial over n minus r factorial. So that is the formula that we're going to use whenever we see an example in a minute. Oh, it's okay. I freaked out before. Thank you. Okay, so for example, permutation. So say you have a box of stress balls, right? And you have 10 stress balls in here. You're wanting to choose 3 of them. So it's like, how many options could I get of choosing 3 out of the 10? So that's what a permutation is. So notice it doesn't matter what order I take them out, right? It's just I'm still going to be left with 3 of them in the end. So that's all we're talking about here. So if I have 3 objects are taken from 10 objects. So if I'm taking out 3 stress balls out of my total 10 that are supposed to be in here. That's what a permutation is. Something like that. We're going to talk about more in a second. So the number of permutations of n items where p items are identical to q items. What the heck's going on here? Let's talk about it. Let's write down the formula first, and then we'll talk about it. So it's given by n factorial over p factorial times q factorial. N factorial divided by p factorial times q factorial. So going back to my stress ball thing. So say if I had, I wish I would have handed it out yet. So say I had 10 balls total. It's okay. 10 balls total. So let's say 3 of them look like this. Actually, can I use yours? 3 of them look like this. And 3 of them look like that tie-dye one. That's my favorite. So, and then the rest, so that would be 9, and there would be 1 other one. So out of those 3, that they're all matching, they're identical, right? They're all the same. So that's where this would come into play. That's where this would come into play because they're all the same, they're identical. So we'll come back to that in a second. So that we can actually see a real life example because I'm really bad at making up examples. And we can see, okay, when do we use which formula? So remember, for a permutation, the order of arrangements matter. We'll talk more about this. It's all just definitions so far. So there are 4 performers who will present their comedy acts this weekend at a comedy club. How many different ways are there to schedule their appearances, right? So automatically I know it's a permutation because there's 4 performers and we need to know, okay, what order are they going to be in? So order matters. We need to know what order they're going to be in, so order matters. So I know to use a permutation, and it's in the permutation section. Kind of cheating. So for our first option, so who's going first times who's going second times who's going third times who's going fourth. Those are our different options for the different orders. For our different orders. So first place, how many different options are there for the the first person to go? How many performers are there? 4. So you have 4 options. There's 4 performers that have the option to go first. So second, how many options of performers are there to go second? 3. Good. 1 person already went first. So now we're left with 3 options to go second. So how many options are there to go third? 2. 2 people are left over. And then last but not least, the last person is left to go fourth. So there's only 1 person to be left over. So we have 4 times 3 times 2 times 1. Again, what's a more efficient way of writing this? 4 factorial. Good. 4 factorial. 4 times 3 times 2 times 1. So it's 4 factorial. So in our calculator, we can do 4, whether you do it in a graphing calculator or a scientific calculator. Hitting the PRB button, scrolling over to our exclamation mark. 4 factorial will give us 24 different options. Done. So here we're looking at the different orders. So we know to use a permutation. So we know there's going to be 4 options for first, 3, 2, and 1. So that would be 4 factorial. Putting that in the calculator, we have 24 different options to schedule their appearances. Questions so far? So remember these come straight from my math lab. Straight from my math lab, so make sure whenever you're doing your homework, you use these notes, so it should be the same questions. So next, if now there's 5 performers who will present their comedy act this weekend at a comedy club, one of the performers insists on being the last stand-up comic of the evening. If this performer's request is granted, if they do get the last choice, how many different ways are there to schedule the appearances? So, going through. So we know that last person is going to get it, right? The last person, we know his wish is going to be granted. He's going to get it. So that's already our 5th place spot. So that's already taking up 1 hole. That's already taking up 1 person. So with that being said, how many people are left over to go first? 4, as I'm holding up the answer. 4. So someone's going to be chose to go first. So how many people are left over to go second? 3, third, 2, fourth, 1. So what is it? So 4 times 3 times 2 times 1 times 1, which is another way of saying 4 factorial, because 1 times 1 is still 1. So we still have 4 factorial, which is what? 24. So because that 1 person requested to go last, they got their wish granted, so we automatically know they're going 5th. That leaves us 4 options to go first, 3 options to go second, 2 options to go third, and then only 1 person's left over that has to go fourth. So 4 times 3 times 2 times 1 is 4 factorial, which is 24. Questions so far? Questions so far? If not, next example. Evaluate 21 factorial divided by 14 factorial. Completely a calculator approach. So in our calculators, we have 21 factorial. So 21, hitting our PRB button and scrolling over to our factorial, divided by 14, PRB, scrolling over to our factorial, should give us 586,051,200. Just put it into your calculator. Just put it into your calculator. Questions for me? How could I help you with that one? How could I help you? If not, let's do the next one. Do I need to show graphing calculator, people? Good? Jamie, you good? Thank you. All right, so evaluate 12 factorial divided by 12 minus 2 factorial. So again, we can put this straight into our calculator exactly like we see it, parentheses and all. So in our calculator, 12, PRB, scrolling over to factorial, 12 factorial, divided by, in parentheses, 12 minus 2. Again, PRB, scrolling over to our factorial. We have 12 factorial divided by 12 minus 2 in parentheses factorial. Boom, that will give us 132. Done. 132. So how could I help you? Oh, it's okay. I freaked out before. It's so recorded. Thank you, then. I don't have the pants tie and then realized the sword. Okay, so questions so far. So if you notice that 12 factorial divided by 12 minus 2 factorial was that formula that we talked about in the beginning, that permutation formula up here, n factorial divided by n minus r factorial. So we already did it. So now they give it to us in the permutation form. So it says 10 permutation 5. All right, so here it's telling us we had 10 items and we're choosing out of that 10 items 5 of them. So if we put this back into our formula setting, we have n items. We're choosing r of them. Our formula is n factorial divided by n minus r factorial. So that tells me n is 10, r is 5. So in our formula, we're going to plug in. If we know n is 10, we have 10 factorial divided by 10 minus 5 factorial. Wherever we see an n, we're going to put 10. Wherever we see an r, we're going to put 5. 10 factorial divided by 10 minus 5 factorial. So just like we did it in our calculator, 10 factorial divided by, in parentheses, 10 minus 5 factorial. I got 30,240. Do we agree? Yes. Perfect. 30,240. No one's going to say anything? Oh, there's a permutation button on there, right? So our calculators already know the formula for permutations. So if we plug in 10, because that's our first number to the left, going back to our PRB button, are you ready? Plugging in 10, going back to our PRB button. The first thing says permutations. Press enter. We're choosing 5 items. Press enter. Boom, same answer. So it already knows the formula for us. So I don't have to do all this work. I just plug it into a calculator. Same answer.
Can you do it one more time?
Yes, I can. Okay, so we have 10 items. So we're plugging in 10. That's our left number. Hitting the PRB button. Our first thing says permutations. That's what I want. I want the P. So press enter. We're choosing 5 items. That was our right number. Press enter. Done. Thank you for asking me. Other questions? Other questions? If not, let's do another example. So it says a club with 11 members is to choose 3 officers, president, vice president, and a secretary treasurer. If each office is to be held by one person, no person can hold more than one office, and how many ways could those offices be filled? All right, so does order matter? Yeah. So order does matter because the first person is going to be president, the second person could be vice president, the third person could be treasurer. So it matters because it matters what position they have to come up with. So it matters. So we know to use a permutation. So how many people are we choosing from? 11. So we have 11 people. We said we're going to use permutations. How many of those 11 are we choosing? 3. Plug into our calculator. We have 11 people. We're choosing 3 of them. So we have 11 people. Using our PRB button, we're going to use our permutation tool. We're choosing 3 of them. Press enter. 990 different options. 990 different ways that those offices could be filled. Questions for me? Questions for me? How can I help you?
If you go online and you go to contact, it is this thing.